Hi there, welcome back to chemistry. My name is Jeremy Krug, and in this video, we're learning about the essentials of reaction stoichiometry. Now, if you're new to my channel, I'd like to welcome you, and I'd like to encourage you to take a look around. Check out the playlists, that's where the action is. If you like what you see and you're able to learn something from my videos, please consider subscribing. That really does help out the algorithm, and that will make sure that you don't miss a thing with regard to my channel here. This is the place for all things honors chemistry and AP chemistry. So welcome aboard. In this video, like I said, we're focusing on reaction stoichiometry. Now, that seems to be kind of a strange word. What does that mean? Well, we can take a look at the roots of the words stoichiometry here, and it literally comes from the Greek that means measuring amounts. And so what we're doing here is we're actually taking a chemical equation or a chemical reaction, and we're talking about how we measure the ratios of different reactants and products in a chemical reaction. Now, before we jump right into reaction stoichiometry here, let's just imagine a similar example, perhaps one that you've seen in your everyday life. Now, here I have an equation, and you might wonder, what in the world is this equation? Well, this is an equation for making a turkey and cheese sandwich. And the way I have this set up here is, in order to make a turkey and cheese sandwich, you need 2 slices of turkey, and you need 1 slice of cheese, and you need 1 slice of lettuce, and I bet you can guess what the B means, right? Bread. And so you need 2 slices of bread. You take those ingredients and you put them all together, and you have a tasty turkey and cheese sandwich. And so this is just an equation here, or a recipe, if you will, that shows how we put the sandwich together and the ratios in which those ingredients are going to be added to each other. So based upon this equation or this recipe here, we can answer some questions. For example, how many slices of turkey are needed to make 10 sandwiches? Well, as you can see here, for every 1 turkey and cheese sandwich, we need 2 slices of turkey. So it's a 1-to-2 ratio. So that means that if we're going to make 10 sandwiches, we're going to need twice as many slices of turkey. So the answer is 20 slices of turkey. Now, what about this question? How many slices of cheese are needed to make 25 sandwiches? Well, if we look at this equation or this recipe, we can see that sandwiches to cheese is a 1-to-1 ratio. So for every 1 sandwich, we need 1 slice of cheese. So 25 sandwiches will require 25 slices of cheese. Now, let's try this question. How many slices of bread are needed to make 50 sandwiches? Well, once again, we can look at the recipe and see that for every 1 sandwich, we need 2 slices of bread. So it's a 1-to-2 ratio. So that means if we have 50 sandwiches, we're going to need twice as many slices of bread. So that's 100 slices of bread. This is just the essentials of how we work with a recipe here. Now you might wonder, what in the world does this have to do with chemistry and with balanced equations? Well, it has everything to do with chemistry, because the fact is we are working with balanced equations in which the coefficients of the balanced equation act as ratios. This actually is a recipe for how the reaction is going to work. Let me show you what I mean here. In this equation, this is telling us that if we have 4 atoms of aluminum and we react that with 3 molecules of oxygen, we're going to produce or yield 2 formula units of aluminum oxide. This is just a recipe or an equation or a ratio here for how those reactants and products are going to be produced and consumed. Most of the time, as I'm sure you're well aware at this point, in the chemistry lab, we're not really interested in counting individual atoms or counting individual molecules or formula units. It would take literally forever to do that. And so that's why instead of talking about molecule ratios or atom ratios, we use mole ratios. And so another way of looking at this equation is to say that if we were to take 4 moles of aluminum and react that with 3 moles of oxygen, it's going to produce 2 moles of aluminum oxide. This is just an equation that shows how the moles are going to work together. And so we say that the coefficients of any balanced equation in chemistry are going to form a mole ratio. And so we can use those numbers in the mole ratio to make calculations based on quantities. So let's take this very same equation here and let's answer this question. How many moles of aluminum oxide can be produced from 4 moles of aluminum? Well, hopefully you can see that the mole ratio of aluminum to aluminum oxide is 4 to 2. So that means 4 moles of aluminum are going to produce 2 moles of aluminum oxide. All we have to do is look at the coefficients of that balanced equation. Or how about this question? How many moles of aluminum oxide can be produced from 8 moles of aluminum? Well, notice that we've basically just doubled the recipe. Instead of starting with 4 moles of aluminum, we're starting with twice as many, 8 moles of aluminum. So that means we're going to have 2 times 2, or 4 moles of aluminum oxide. All we've done is we've doubled the recipe here. In the next question, it says how many moles of aluminum oxide can be produced from 3 moles of oxygen? Once again, we're just looking at those coefficients in the balanced equation. 3 moles of O2 are going to produce 2 moles of aluminum oxide. We just look at the coefficients of the balanced equation. How about this one here? How many moles of aluminum oxide can be produced from 12 moles of oxygen? Well, notice that the mole ratio of oxygen to aluminum oxide is 3 to 2. But this time, we don't have 3 moles of oxygen. We have 4 times as many, don't we? We have actually 12 moles of oxygen. It's almost like we've quadrupled the recipe. So if we're starting with 4 times as many moles of oxygen, then we're going to end up with 4 times as many moles of aluminum oxide. So 2 times 4 is 8. So we're going to make 8 moles of aluminum oxide. This is how mole ratios work. Now let's try a different equation here. In this case, we have a single replacement reaction where we have 2 moles of sodium reacting with 1 mole of lead 2 nitrate to make 2 moles of sodium nitrate and 1 mole of lead. And the first question says, how many moles of lead can be produced from 2 moles of sodium? Well, just like in that last example, I hope you can see that we're just looking at the coefficients here. If we start with 2 moles of Na, then that means we're going to have 1 mole of lead because that's the coefficient of Pb. How about this question? How many moles of lead can be produced from 0.55 moles of lead 2 nitrate? Well, let's think about this in terms of the mole ratio. The mole ratio of lead 2 nitrate to lead metal is 1 to 1. And we say that because their coefficients are the same. 1 right here and a 1 right there. So however many moles of lead 2 nitrate we start with will be the same as the number of moles of lead metal that we're going to end up with. So if we start with 0.55 moles of this reactant, we're going to end up with 0.55 moles of that lead product. So that 1-to-1 ratio gives us the answer. How about this one? How many moles of sodium nitrate can be produced from 6.1 moles of lead 2 nitrate? Well, notice that this time the mole ratio is 1 to 2. It takes 1 mole of lead 2 nitrate to produce 2 moles of sodium nitrate. Those are right out of the coefficients of the balanced equation. So what that means is, however many moles of lead 2 nitrate we have, we need twice as many moles of sodium nitrate. So if we're starting with 6.1 moles of lead nitrate, we just times that number by 2, don't we, to find moles of sodium nitrate. So 6.1 times 2, of course, is just 12.2 moles of sodium nitrate. So this is how we can work with the coefficients of a balanced equation and determine the mole ratio here and get some quantities out of that. Hey, hope you learned something from this video. If you did, please smash that like button. I would really appreciate it. That way, these videos will be shared with other great chemistry students like yourself who want to learn about chemistry as well. Thanks for watching. In my next video, we're going to learn how to calculate values other than just moles, and we'll add in how to convert to grams, liters, and some other units as well. Thanks for watching. I'll see you in the next video.